At the government level, preparing for a catastrophic solar storm has evolved from being a niche scientific concern to a full-scale national security priority. Why? Because a single solar event could do more damage than any cyber attack, military strike, or natural disaster in modern history. At Infinity Beyond, we take you inside the growing global response and why politicians, scientists, and military leaders are finally taking space weather seriously. In the United States, the White House, Department of Homeland Security, DHS, and Department of Defense, DoD, have issued several national action plans to address space weather risks. In 2019, the National Space Weather Strategy and Action Plan was released, outlining objectives to improve forecasting through satellite investment, protect critical infrastructure like transformers and satellites, coordinate federal response protocols in the event of a major solar event. The Federal Energy Regulatory Commission, FERC, now requires utilities to harden their infrastructure against geomagnetic disturbances, including simulations and stress testing of power systems. The European Space Agency, ESA, is developing its Lagrange Space Weather Mission, which will sit at Lagrange Point 5 to provide advance warning of Earth-directed CMEs, potentially hours or days ahead of impact. Meanwhile, the UK's Met Office Space Weather Operations Centre and the German Aerospace Centre are conducting national grid vulnerability studies. In Sweden and Finland, both countries with high geomagnetic risk, governments are investing in modular transformers, hardened substations, and public resilience education. Japan, vulnerable both to solar storms and earthquakes, now integrates space weather data into its national disaster warning systems. China is building a network of space weather observatories linked to its satellite fleet and military assets. India has launched the Aditya L1 mission, its first space-based solar observatory to monitor the Sun from the Lagrange point L1. These regional efforts reflect a growing consensus. The next global catastrophe may not come from Earth, but from the Sun. International collaborations are also strengthening. NASA and ESA regularly share solar data. The International Space Environment Service, ISES, coordinates 18 space weather centers worldwide. There are even military-to-military briefings on solar risk as it pertains to satellite defense, missile guidance systems, and undersea communication cables. The United Nations has even discussed space weather at the level of disaster risk reduction, recognizing that a Carrington-class event could qualify as a global humanitarian crisis. At Infinity Beyond, we ask, will this preparation be enough? Some experts worry that planning is still too slow, too underfunded, and too reactive. Global power grids remain deeply interconnected and largely exposed. And supply chains for critical equipment, like high-voltage transformers and radiation-hardened chips, are still fragile. In our next segment, we'll examine the future of solar defense, how humanity might one day build spacecraft shields, magnetic deflectors, or even orbital solar observatories that guard the Earth like planetary armor. Because the more we depend on technology, the more we must defend it from the sky. What does the future of solar defense look like? At Infinity Beyond, we envision a world where Earth isn't just a passive target for solar storms, but a planet actively shielded by technology, prepared not only to predict solar threats, but to intercept, absorb, or even deflect them. Let's explore the emerging ideas that may one day form a protective barrier between us and the Sun. One concept under discussion is the use of space-based magnetic shields, giant satellites placed at Lagrange point L1, which could generate powerful magnetic fields or plasma bubbles to deflect or weaken solar particle streams. This would be the first artificial magnetosphere ever created, essentially an electromagnetic umbrella between the Sun and Earth. The idea sounds like science fiction, but some models suggest a plasma sail or magnetic loop system could redirect enough particles to significantly reduce CME damage, especially if deployed far from Earth to allow early deflection. Future satellites and power grid components may be built with radiation-hardened materials using nanotechnology. These materials would insulate critical systems from both high-energy proton bombardments and electromagnetic surges. NASA is already testing self-healing materials inspired by biology that can seal radiation-induced microfractures in spacecraft hulls. Think of it as smart skin for machines, capable of repairing itself after a solar hit. A fully integrated global system of low Earth orbit, LEO, and deep space solar observatories could form a real-time solar surveillance net. Each observatory would monitor solar flares, CMEs, and solar wind patterns with AI-assisted diagnostics, sending alerts to Earth in seconds. Imagine this as an orbital shield of eyes, constantly watching the sun's every move, capable of triangulating the direction and intensity of any incoming solar storm. The goal? Global warning within 60 seconds. Building on models like Dagger, future AI systems could evolve into autonomous decision hubs, capable not only of predicting, but also of initiating automated defense responses. Power grid modulation, satellite orbital adjustments, drone rerouting, civil alert broadcasts. AI would serve as the brain of planetary defense, responding far faster than human analysts ever could. Following in the wake of the Parker Solar Probe and Solar Orbiter, next-generation missions may attempt to collect solar particles in real time, return them to Earth, and help scientists understand the precise behavior of solar magnetic fields at the source. This would be the equivalent of sampling the sun's blood, giving us deeper insight into its cycles and its tempers. Some theorists propose building solar weather stations on the Moon, where observatories could operate without atmospheric interference. Others dream of an eventual lunar far-side shield, a base that could double as both a defense system and an early warning platform. At Infinity Beyond, we believe that space is no longer the final frontier. It is our newest battlefield, but not one of weapons or conquest. It is a battlefield of resilience, knowledge, and cooperation to protect Earth from a threat as old as light itself. In our next segment, we'll reflect on the spiritual and philosophical questions raised by our star. What does the sun represent to humanity? A god, a giver of life, or a destroyer of civilizations? Because to understand the sun is not just to understand the universe, it is to understand ourselves.